in the domain of some function. So the first function they give us is f of x is equal to the square root of x plus 3. Alright, and we're asked to find the domain. We'll call this hashtag domain probs. Okay, domain probs. So what are the problems with domain? There's two. Can't take the square root of a negative number. And any number over 0. So the denominator can't equal 0. And you can't have a negative even root. You can't do it. You can't take an even root. We always say square root, but that applies to a fourth root, a sixth root. Because anytime you multiply a number by itself, whether it starts off as a positive or a negative number, it always ends up positive. So when you reverse that process, you can't do it because there is no number that you can multiply by itself to get a negative number. Does that make sense? So that's a domain restriction. This is domain restriction number 1, domain restriction number 2. And so what we need to make sure is that if I plug in a number for x, for example, if I were to plug in negative 10 for x, would that work? Why? Because you'd have a negative square root, and we can't do that. So what would I need to think about? Well, what I need to think about, so whenever I see a square root symbol, the radical symbol, automatically a red flag should go up. Domain problem. Okay? If I see a fraction, automatically I got to think there may be a domain problem. If I don't see a square root symbol and I don't see a fraction, I really could pretty much, for the most part, the domain will always be all real numbers. Very rarely, unless we get into some special functions. But for polynomial and rational expressions and stuff like that, these are the two main ones, right? When you do like there's some special functions that you have to think about, and we'll address those later. But for now, focus on this. So what does this mean? It means that x plus 3, it can't be negative. So what's a fancy math way of saying it can't be negative? Greater than or equal to 0. Does that make sense? So if I just subtract 3 from both sides, I get x is greater than or equal to negative 3. That is my domain. My corresponding range is based on this domain. So if I were to find the range, I could evaluate the function at negative 3. This is my lower boundary. Now I can't give you a cookie cutter recipe to tell you how to figure out the range. I mean, we're going to graph this in about 2 seconds and look at it and see what the range is. But if I plug in a number bigger than negative 3, if I plug in 10 million for x, I get the square root of 10 million and 3, which is a positive number. So every number is going to be greater than 3. In other words, what I'm trying to say is y is greater than or equal to 3. Now there's lots of ways to write the domain. What's another way I could write it? I could say the domain is from negative 3 to positive infinity. I could say that the range is from 0 to positive infinity. Now what does this look like graphically? I don't know, let's plug it in and see. So if I take the square root of x plus 3, plug it in, hit graph, notice as we follow the path of the curve, once I get to -3, it becomes no more. There is no corresponding y value. We could also look at the table of values as well. Once I get to -3, no more function. Now, what I could do is I could, if this is the lower boundary of the function, and we'll talk more about that tomorrow, I could see clearly by looking at the table of values, x will increase forever, as will y. So basically what I've written down on my paper is correct. Are there any questions?